Ok. Ok. Allora, questa è la registrazione del nostro appuntamento di 22 dicembre. Abbiamo solo esercizi, esempi, e la vostra prima domanda è quale esercizio, se lei può condividere lo schermo?
Sì, però ho scritto sul quaderno, quindi non ho una copia sul...
Allora, se lei accende il video e lo avvicina, così cerco di copiarlo sul foglio che ce l'ho. Se può accendere il video e mostrarmi sul video, vicino al video, quello che aveva sul quaderno.
Sì.
Benissimo. Sì, sì, vedo benissimo. Qual è l'esercizio?
Era exponential random variable e trovare expectation e variance.
Ok, è l'esponente meno lambda x, ok, lambda quando x è positivo e 0 quando x è negativo. Perfetto, questa è la domanda che riguarda, grazie, riguarda la seconda parte di quello che pensavo di fare. Per quello prima, se let's switch to English. So, our first step shall be to see examples for 2x2 systems. To show one example, then to show you example to try, and then we shall switch to your question for the exponential density, how we can compute the expectation and the other moments that are necessary. Okay, let's go to the whiteboard, if you don't mind. And clean first. Okay. Can you see well the screen?
Yes.
Okay. Any problem you have, please to inform me, to stop for a while and wait better connection, because from time to time the EduROM connection at University of Pisa, so many colleagues are using the EduROM net, and it has some problems. Okay. So let us start with our first typical example. As I told you, the first part shall be to make a small example, so you shall have a few minutes to prepare and then to start to see examples of this type. So, typical example was system 2x2 of differential equations. Let us complete the cleaning. Okay, one typical example is the following one. I shall start to write here. Okay, if I understand correctly and can write till this point. If I am outside the field, please to let me know. So we have the following system. X prime of t is 17xt minus 48 epsilon t. Then we have epsilon prime of t equal 8xt minus 27 yt. The question is, oh, probably you cannot see well. Let us take, now probably is better. The question is to see 0, 0, obviously 0, 0, the point 0, 0 is equilibrium point, stationary point, and to show the type, is it fuoco, saddle point, or we have knot. Describe the type of 0. That means to find eigenvalues of the corresponding matrix. What is the matrix we have in this case? This is the matrix with these components: 17 minus 48, 8 minus 27. So what we need is to find characteristic eigenvalues, the characteristic equation. So we take minus lambda here, consider this determinant, and compute. How we compute this determinant? This by this minus this by this. So we write 17 minus lambda minus 27 minus lambda, and then we have minus this product. We have plus 48 by 8. Let us simplify. This means that we have to open the brackets. Minus lambda by minus lambda gives lambda square. Then we have minus lambda by minus 27, this by this plus 17, minus 27 plus 17. One moment, there is a message. Ok, mi avete segnalato cattivo collegamento. Aspettiamo un attimo. Tutti hanno problemi della rete in momento?
Io per ora vedo bene.
Anch'io
Ok.
per ora vedo bene.
Ok.
Anch'io vedo bene.
Ok, questo più o meno mi dice che non è problema della rete al dipartimento, e forse Asia ha chiesto questo problema? Ah, va bene, microfono non è importante. Ok, allora, no, nessun problema. Probabilmente questo è importante perché noi adesso registriamo. Dopo, quando lei scarica il video, vedrà che non ci sono problemi. Il problema è che quando tutti vedono male, poi il video esce male e significa problema locale. Va bene, allora continuo. E ogni volta quando avete qualche problema è meglio di interrompere e di vedere. Ok. Abbiamo detto meno per meno ci dà più 27 lambda, meno 17 lambda, questo ci dà più 10 lambda. E alla fine devo moltiplicare 27 per 17 con segno meno e aggiungere 48 per 8. 48 per 8 mi dà subito 4 alla fine, 3, 2 più 6, 38, 384. Quando moltiplichiamo 17 per 27, il risultato è 459. Potete verificare che 48 17 per 27 dà questa somma, questo prodotto, e adesso devo prendere questo che era 30,84 con segno più, mentre 459 con segno meno, ma io prendo la differenza e qui come vedete c'è 75 e lo scrivo con segno meno 75. Ok, questo significa 48 per 8 meno 17 per 27, potete usare calcolatrici durante la verifica, mi dà 75. E quali sono adesso lambda 1 e lambda 2? Proviamo a vedere se avete idea come potete trovarli. Certo, la via più lunga è di cercarli, lambda 1 e lambda 2, con le formule. Ma proviamo a vedere se avete modo più veloce. Proviamo a vedere come potete risolvere. Quali sono lambda 1 e lambda 2? Le due radici di questa equazione, di questo polinomio caratteristico, quando si deve risolvere questa equazione uguale a 0, quali sono lambda 1 e lambda 2? Potete proporre qualche soluzione?
A me è risultato meno 15 mezzi e più 5 mezzi.
5 mezzi. Perché viene questo 5 mezzi? Io vedo una soluzione lambda uguale a 5, ad occhio. Da dove è venuto questo 5
ho sbagliato la formula, 5 meno 15, ho sbagliato la formula, ho fatto un mischione nelle formule.
Va bene, e per quello lavoriamo insieme, è meglio imparare con errori. Anche io faccio errori, quindi bisogna imparare con gli errori. Quindi gli altri hanno la stessa. Qui per esempio per me è importante di usare le formule di François Viet. Non so se avete nella scuola superiore le formule di Viet che dicono lambda 1 per lambda 2 è uguale a qualcosa e l'altra relazione di Viet è lambda 1 più lambda 2 è uguale a qualcosa. Che cosa ci dice Viet? Prodotto tra i due deve darci meno 75, che è C diviso a A. Lambda 1 più lambda 2 deve darci meno questo per questo, cioè meno 10. E allora abbiamo trovato uno di autovalori è lambda 1, 5. Quale sarà lambda 2? Subito si vede da questa relazione più semplice. Se lambda 1 è 5, se trovate 1, l'altro è meno 15. Certo, in questi esempi io cercherò sempre di avere radici che sono semplici, qualche conticino va fatto in ogni caso, così potete utilizzare i calcolatrici dei cellulari e alla fine bisogna risolvere questa equazione e risolvendo si trova lambda 1 e lambda 2. La conclusione, che cosa abbiamo? Qual è English. So what type of eigenvalue we have? What type of stationary point, equilibrium point we have? Yes?
Stable.
Saddle point, yes. This is saddle point. And therefore we have saddle point. In italiano come si diceva?
Sella.
Sella, esatto. Quindi abbiamo questo tipo e adesso vi do un esercizio che potete provare a casa dello stesso tipo e poi potete vedere qual è il tipo del... prima di cancellare e mettere completamente, vorrei che I want to ask you if you have some questions for this solution. This is very simple example, and as usual on the exam, you are not mathematicians, but some small practical calculations you have to do, and therefore this is a typical example. If you have some question,
I have a question because
please.
I remember that when we were doing these examples, usually we did the Taylor expansions near
Yes,
the
this is the
stationary.
next example.
Ah,
Look,
okay.
for the written example, I shall not give you very complicated things. Or you shall have this, or you shall have some function for which you compute the Taylor expansion. But you shall not do this because this is to make Taylor expansion and then eigenvalues is long project. We have relatively short discussion. We need to have small pieces. So you shall prepare each piece, and in this way you shall be ready. In this way, when you have real problem, you can solve in the future probably. If you collaborate with some mathematician, you can understand all steps. But here we need, for the exam, divide in small pieces. So we shall speak about Taylor after. Other questions? Okay. Okay, if it is clear, let me make the next example. 14, and this is minus 36. Here we have 6, and here we have this. You can try at home. Okay. Now we shall clean. And we shall go further with, as you already discussed, Taylor expansion. Typical example, this is at home. This example. Now, the next example is again 2 by 2 system, but you have x prime of t is cosine of x square plus epsilon square. This is of t, and epsilon prime of t is equal, for example, epsilon x, epsilon of t times x of t. So what we need to find critical points, stationary points. Therefore, we have to solve the following system, that is cosine x plus epsilon equals 0, x epsilon equals 0 to find all solutions x epsilon. And then if you find the points where x epsilon satisfies these equations, around these points to make Taylor expansion. Actually, we shall restrict our question because, as I told you, we shall have small examples. So if this is x epsilon, we shall look and we shall specify that we are looking for solutions of this equation only in this square. That is minus p, p. This is minus p, p. And we are looking only for xy to be inside. Inside, not the boundary is forbidden. We need strictly inside. This, of course, means that we shall have some solutions, and from all solutions, we shall find only the solutions inside our square. You know, when xy is 0, or x is 0, or y is 0. So we have case 1. Let us call this system 1. Case x equals 0. This is the first case. Of course, if x is 0, second equation is satisfied, and you have to solve cosine of y equal, sorry, here I made a mistake. This is square. Cosine y square equals 0. Cosine of something equals 0. What does it mean, this argument? Can you help me? What is the solution? Or which are the solutions? Yes. If you have some difficulty for the moment, you can use also Mr. Google or some other source. Cosine of something equals 0. Please to use any help. Important thing is you communicate, you collaborate with some source, and you take from there the result. Yes, you can say. Let's cosine of something equals 0. What is this expression? Which are the angles such that cosine is 0?
Pi.
Cosine of pi is how much? This is important. Now I shall clean this again. We shall make always when you have difficulties with this sine, cosine, make trigonometric circle in order to so this is our trigonometric circle. Radius is 1. For example, when we have angle, we can say theta, what was cosine, what was sine? This is O, A, B. What is sine, what is cosine of theta? Sine is, yes?
Dia.
Exactly. Sine is AB. Cosine? What is cosine?
0b.
OB. Okay. Now you're saying the following. Let us take pi. So my point A is here. What is OA? Cosine of pi. Look at the picture. What are the coordinates? So if I call this point A, which are the coordinates? The first point is cosine theta, x argument, horizontal, sine theta is vertical. What is the horizontal point, horizontal coordinate, first coordinate of A? here. This is +1 and this is
-1.
-1. So cosine of pi is exactly -1. It's not appropriate for our purpose. When cosine is 0, so in this case, of course, you see A and B, they coincide. When you put your angle P is here. If I take P over 2, if my point A is here, what is the first coordinate of A? In this case, when I have P over 2. What is this?
Zero.
0, because you see, when you take your point, X is the projection on horizontal X, and therefore it is 0. I'm not interested in sine. Cosine P over 2 is 0. Can you find another angle such that cosine is 0? Look at our circle. If I go in this direction, this is P over 2. If I go in this direction, what is this guy? This corresponds to plus P over 2, and this? Angle in opposite direction. Therefore, the angle shall have sine. What do you think?
Minus.
Minus. So you have also cosine of minus P over 2 is also 0 from the picture. This coincides with the fact that cosine is even function. So if you have minus, this is the same as the value with plus. But I can do another thing. I can make, once I go here, P over 2, and then I make another circle and turn back. This means one circle is how many pi? If you make one turn, complete turn. One complete circle is proportional to pi, but what is coefficient? One complete circle is 360 degrees.
2 pi.
2 pi. Therefore, we can say cosine of P over 2 plus 2 pi, because cosine has periodicity 2 pi is again 0. And you can make any number of circles. So you can put here any kappa to find 0. But you can make also here cosine of minus P over 2 plus 2 pi kappa. And here we found all solutions. This means our expression, if cosine of something is 0, this shall be or plus or minus P over 2 plus 2 kappa pi. This is very important observation. When you have to solve equation like this, you have to use trigonometric circle, and you have to have this simple calculation. Where is cosine? Cosine is the first coordinates. If you have to compute sine, this is the second coordinate. And then you see when you make, when you turn around, when you change your angle theta, you see how cosine changes, and you compute cosine at P over 2, at P minus 2, when you have cosine of something equals 0. And these are all solutions. All solutions. because you have two possibilities, or this point or this point. If you have different points, always x coordinates is not 0. So this cosine equals 0 means you have these solutions. Now, what we have to do? We have to take epsilon square equal this guy. Of course, this means that actually, let us simplify our equation. Clean squares, this is too complicated. For the final discussion, we shall need something very simple to be sure that this is true. So if you clean this square, the situation is more simpler, and we can say that epsilon, in this case, is exactly this one. Now, the question is, x0, epsilon, this where is in our picture? x0 means we are on this line. First, we take kappa 0, plus minus p over 2. P over 2 is here. P over 2, and this shall be minus p over 2. So here we have 2 points. X epsilon that satisfy 1. What shall be the next point? If I take kappa equal 1, what will happen? For example, p over 2 plus 2p. This is much bigger, and we are outside our square. So you can check that on this horizontal, on x equals 0, therefore on the vertical line, we have only these 2 points. And since here x and epsilon, they have the similar, we can exchange the row of x and epsilon. We can say also in the case 2, epsilon is 0, but in this case we have x is plus minus p over 2. From the picture, we see these are 2 points. This is p over 2, this is minus p over 2, and these 2 points are unique points on the horizontal line that satisfy this equation. And therefore, you have 4 points. Typically, our questions for the final discussion can be divided in 3 different types. First is to see the type of the stationary point. Therefore, if this is saddle, not point, and so on. Second is of this type, find stationary points in some domain, and this is the procedure. And the third point is your stationary point shall be given. For example, we take for this system point with x coordinate 0 and epsilon coordinate p over 2, and we are asking make Taylor expansion. I think since we did several times the Taylor expansion, I shall put this question, but before writing this second, actually the third example, let me ask you if this procedure, this kind of treatment is clear for you, if you have some questions.
In the second case, we should write also 2k pi.
Yes, exactly. And then you shall say to be inside the square, we have to take only kappa equals 0 because other points are outside. This is sufficient for me to understand that you clearly, because what is the next point? If this is pi, you take p over 2 plus 2 pi. 2 plus 1/2 gives you 5 over 2. 5 over 2 is much bigger. And therefore, I understand that you selected only these 2 points. At the beginning, you write 2 kappa pi, but then you mention that kappa shall be chosen only in appropriate way to satisfy the condition that stationary point is inside the domain that is fixed from the beginning. We are interested in the square. This means kappa cannot be 1, cannot be 2. Neither kappa cannot be, for example, if you take, for example, minus p over 2 plus 2 pi. What is this guy? What is 6? No, epsilon. Minus half plus 2. This gives us 3 halves. 3 halves pi is above pi, and therefore outside. So you're right, it is the only points that are inside the square are minus p over 2 and p over 2. Is it clear, the answer?
Yes.
Okay. Okay. Other questions? Okay. Now, let me write one example that you can try to prepare at home. This is at home. Is the following example. X prime is equal x plus epsilon. And then you have epsilon prime equal sine of x minus epsilon.
Sorry, we cannot see.
Now?
Yes, thank you.
Okay, thank you for... let me repeat. We are looking for stationary points. And I shall make a small picture. Again, we have the square minus pi, this is pi, this is minus pi, inside this square. You shall not look for all possible stationary points. I can immediately recognize that both guys are 0 at the origin, but you have to find eventually other points. So this is the question for repeating what we did to make the trigonometric circle and solve this trigonometric equation. I know that this is one of the most, how to say, the arguments that are more complicated for students and create difficulties. But for the simplest cases of simple trigonometric equations, small ability you need to manifest working only with trigonometric circle. Okay, now we are going to the next example. We shall take this stationary point for our previous example, and we shall make Taylor expansion. This is the last question that has to be answered. Of course, during our final discussion, you shall not have 3 different questions. Usually we have 1-2 practical questions. If you solve the first practical question, we can turn to the oral part. If you cannot solve the first practical, I shall pose second practical question, and therefore we shall try to find the symbiosis, the average between these 2 examples, and then we turn again to the oral part, to the, the theoretical part. Now, let us try to pose the question, the next question. If the question for solving at home is clear, I can clean this part to pose the next question. If you have something not clear here, please to tell me. If the question is clear, you can try to do this, and I am going further with the next step, that is we're looking for Taylor expansion of one. The question is make Taylor expansion of one near, close, near the point 0 p over 2. So x is 0, y is p over 2. For this, we, of course, shall call this function f of xy, and we recall again what is the Taylor expansion of function of two variables around x0, y0, fixed point. In our case, 0 is 0, y0 is p over 2. But the question is the following: how to make Taylor expansion of this guy near this point? And of course, to answer to this question, we have to recall the fact that fxy was, Taylor expansion was fx0, y0 plus partial derivative with respect to x of f at the point x0, y0 times x minus x0 plus partial derivative with respect to y at the point x0, y0 times y minus y0 plus, and here we have remainder that is of higher order. The important things are these guys. Here, this we shall forget about. We said that our linearization Taylor expansion near this stationary point means that we simply neglect the remainders, and that's why the key point here is to apply this formula. So I shall clean this part of the solution of the previous question and shall write the Taylor expansion near the point that is required. Already this geometric picture is necessary. Actually, I shall write, is this angle seen well? I prefer to write our system here in order to have space for writing. So our system is x prime was cosine x plus y, y prime was xy. Sorry for this, this is only to remind me. I know that some of you, they have problems, they prefer bigger writing, but here I shall write bigger letters. This is simply a repetition of this guy. First, we take the function cosine x plus y. This is the first function. And we have to compute. We know very well that in stationary points, the first term is always 0. So we have to start directly from the second one. What is the partial derivative of this function? The partial derivative means that we epsilon and consider x as a variable. What is derivative of cosine? When you take derivative of cosine, you have, what shall I write as first term? Derivative of cosine is yes,
minus sine.
Minus sine, and I shall put the same argument, x plus y, times the derivative of x, but the derivative of x is 1, therefore I shall write nothing. If instead of x here I would have x squared, then here I have to put x squared, and here I have to put the derivative of x squared. So if here we have expression in general, then here we shall put the derivative of the expression. But here the derivative of x, fortunately, is 1. And there is another important thing. Remember that here we have to put 0, 0. I shall put for the moment 0, 0, and then shall substitute with 0 p over 2. Then I continue to write x minus x0. I would suggest you as a first step to write with generic x0, epsilon 0, and then on the next step to substitute. Plus, now you can help me. What is the derivative in epsilon of this function? Still we have cosine, therefore derivative shall be again minus sine. I have to put x0 plus epsilon 0. The derivative of epsilon is 1, so I shall write nothing. This is my partial derivative. And then we have epsilon minus epsilon 0. Okay, now it's time to substitute x0 with 0, epsilon 0 with p over 2. But then I have to compute sine of p over 2. Remembering our trigonometric circle, what is sine of p over 2? Can you help me? What is the sine of p over 2? Sine was the second coordinate.
1.
1. Perfect. So this is 1. This I need, so I can write. Here I shall make help calculation with sine. So we have equal minus sine of p over 2. So this is minus 1, x minus x0. Now I substitute x0 with 0. Then we have minus sine, the same argument. So again, I have minus 1, epsilon minus. Now I substitute epsilon 0 with p over 2. So what is the final result? Minus x minus epsilon plus p over 2. And we are done. Our function, the first function is Taylor expansion is applied. Now we have to go to the second one, which is simpler, and therefore I have to write x times epsilon. Still, I use the same formula. I know that in 0 p over the first guy is 0, and I have to compute what is the partial derivative with respect to x of this function. This is my function. What is the partial derivative with respect to x? Yes? Partial derivative with respect to x means epsilon is fixed Yes, Asia responded epsilon. The partial derivative with respect to x is epsilon, but I have to substitute what is written here, epsilon 0. Perfect. Times x minus x0. I am writing x minus x0. I am writing what is written from my Taylor expansion. Now, what is the partial derivative with respect to epsilon of my function? Of course, this is x. And I have to substitute x as it is written here with x con 0 plus x con 0. And then I have to write epsilon minus epsilon 0. Now, in the last step, I substitute plus remainder, of course, but we said that we neglect the remainder. Now I substitute x0 epsilon 0 with what is written there. Epsilon 0 is p over 2 times x, x0 is 0. If x0 is 0, obviously this product is 0. So we have the Taylor expansion and you answer the question. So this is more or less example of the following type, and as you can see, we have 3 types of examples, and you can proceed further. Choose, for the example I propose you at home, 1 stationary point and make Taylor expansion around this point. If you change the stationary points, you can make other examples. And if you want, tomorrow, as we planned, we can compare your replies with our replies, and I can check your answers. Okay, perfect. I have the following proposition: to make small break, 5-10 minutes, and then to turn to probability part, probability and statistic. Part with the same plan. First, to answer to your question about exponential distribution, and then to make some examples and leave you again few questions to try at home. Also, after the break, you can pose some questions if some parts of what we have done remains unclear. Okay. Let us stop to register. I hope the quality was good during this first part. There was some interrupt. Yes?
Was good.
Okay. Also for others, if I have 2-3 confirms, shall be sure that this is okay.
Yeah.
Okay. Okay. Very good. Thank you very much. Stop.